Okay, question number 9. The position of a particle is given by the parametric equations x of t equals 3t squared and y of t equals 2 root t. Find the speed of the particle at t equals 4. So when we're asked a question about speed, before we can do the problem, we have to remember the formula for speed, which is the square root of x prime of t squared plus y prime of t squared. So since we were given the original equations, definitely want to find x prime of t and y prime of t. So x prime of t is 6t. For y prime of t, it might be helpful to rewrite y of t as 2t to the 1/2. Then we can just do the power rule with it. We multiply by 1/2. We just get 1t to the negative 1/2. So we plug that into the speed equation. And we've got 6t squared plus t to the negative 1/2 squared. And this speed equation will give us the speed at any value of t. This question specifically asking for the value of the speed at t equals 4. So all I have to do is plug in 4. That would give me 24 squared plus, now if I plug 4 into this, 4 to the negative 1/2, that's the same as just 1/2, but I'll write it like that. And then you guys can just throw that into your calculator. Speed comes out to be 24.005. The acceleration vector for part B. The acceleration vector is going to be equal to the second derivative of our position vector. Well, we've got the first derivative pieces up here. So what's required is just to do another derivative. So the derivative of 6t is 6. The derivative of t to the negative 1/2 is going to be negative 1/2 t to the negative 3/2. That is our acceleration vector. We're specifically asked in this case to find the acceleration vector at 4. So when I plug 4 in, and for my x component, that's going to be 6 no matter what t is. And then we'll get negative 1/2 times 4 to the negative 3/2. I know that negative exponent is causing some stress. Good thing you can plug it at the calculator. Reduce it how you will, but that second number does come out to be negative 1/16. And we get a 6 for our first value. So that is our acceleration vector at t equals 4. Final question of part 9. It says find the distance the particle from question 9 travels from t equals 2 to t equals 5. We used this formula earlier, but the total, this is an arc length or total distance traveled. So we're going to do the integral from a to b of the square root of x prime of t squared plus y prime of t squared. We've got x prime of t and y prime of t, so I'm just going to grab those from further up in the problem. And it tells us our endpoints, 2 and 5. So we're going to do the integral from 2 to 5 of the square root of 6t squared plus y to the negative 1/2. Oh, I'm sorry, that's a t. Whoops. Squared dt. And then, again, however you want to plug this into the calculator, remember I showed you the trick earlier where you'd want to plug the 6t into x sub 1, or y sub 1, t to the negative 1/2 into y sub 2. It simplifies it, you don't have to worry so much about the exponents. But when you plug this in, you should end up getting 63.025 for that answer.